Welcome to Simtek. I'm Jay and I'm the Technical Director, and today we're going to discuss the pros and cons of fuses, relays and body control modules. And I've got some examples here behind me that we'll be able to show you, and we're going to start with what you might have when you've taken a donor car to build your 7 or whatever you've chosen to excite yourself with. And this is a good example. This is a good example of a late 1990, 2000 car's front wiring loom and its fuse box. It's a quite competent car, so it's got electric heated front screen and this sort of thing. Lots of components on it that you won't need in your car and you'll be removing from it, and it will require you to open the whole loom up and remove out what you don't want. Otherwise you'll have a very messy loom. The big problem with this sort of system is that it'll not really fit your car. This is meant for an Escort, as it happened to be, the last of the line, and that layout won't suit your, say, Westfield 7. So you might consider building your own wiring loom, starting from fresh and using fuses and relays. And this layout here is what you probably end up with. It looks quite a lot, but actually it's just about what you need. Fuel pump relays, spotlights or headlight relays, a cooling fan, wiper control relay, because you'll be using the original wiper motor, and that will need a very specific relay to control it, and this happens to be a Ford one. And then you'll want some fuses. Now some people go for a much diminished number of fuses, but I prefer to fuse everything, and then that helps you when you're doing diagnostics if you've got issues. And then we'll compare this system to the body control module that was one of our products. There are other people who make these, of course, and they all have the same benefits and disadvantages, so we'll talk about that. This unit was a display stand, as you can see. It's not meant to actually run a vehicle, and one of our technicians who've been with us for a number of years and is quite competent at building wiring looms, this took him a day and a half on the bench to create, and all it's there to show is the number of relays and the number of fuses you will expect to use on a vehicle. So when you come to design your system and choose what controls you're using and how many functions you want on the system, you have to consider that you in your garage or your workshop will be making it if you're competent and happy to do your own. This took us a day and a half. With the body modules and things like that, you can much reduce that time because we do all the work electronically and on the PCB inside the board. Now, fuses and relays are very discreet, so if something breaks you can unplug it and you can see it. Relays are very reliable. Some of the timer ones less so if you have some of the older Volkswagen vehicles. Fuses are very easy to change, but this is where you have to start considering some interesting things about diagnostics. People think that a fuse blows and that is the fault. Fuses are a symptom of the failure, not the cause of the failure. So it's nice to have them on view, and people do ask us, oh, where do your unit doesn't have a fuse? Well, they do have fuses, but they're doing the job for you behind the scenes. So the advantage of this is if you are scared of electronics, which you probably aren't really because you'll have a mobile phone, you can see everything in great detail. The disadvantages is that to get nice functionality, modern controls, IVA compliance, you need a lot more interlocks, wires going from A to B. You need to plan your system out. So if you started by drawing up your system, that's quite simple compared to planning your fuse and relay box. The disadvantages of these systems is it's relatively open. It can get water in it. You can wire it up wrong in the very beginning and cause yourself an issue from the start. and you need a massive amount of space. Behind your dashboard, you've got to be able to get that loom either made on the vehicle, or you've got to be able to make it on your bench and fit it. And you've then got to consider grommets and mounting. And then you've got one final issue with fuses and relays. If you're in a rugged environment, so you've got your open-topped 7 and you're going to go track daying, there's a lot of vibration put into these. If you don't mount them right, they can come out, the fuses can drop out. Not that common, but it does happen. We build racing car harnesses and have had these issues with customers in the past. So we've been building these for 20 odd years, and that amount of time it takes to make these systems started to make us think about what you could do differently. And in motorsport for a long time, they've had what they call PDMs. And PDMs are power distribution modules, and they're an electronic version of what you see here. However, they're not that versatile for the use of road vehicles, and they're very complicated to program if you're not into that sort of thing. So we developed the body control module range, which gives you programmability so you can select certain special functions, but it does everything for you without you having to think about it. It eliminates all the fuses and relays. They're still there, but in a different format, and it allows you to have much more interrelated functions. So if you put your headlights on, your side lights will automatically come on. The sorts of things that are required by IVA, but also the sorts of things you're used to when you get in your standard road car and it just works. And I believe that whilst you're building a kit car or a sports car or a race car for the enjoyment, you don't have to sacrifice it just doing the job right. And in fact, if it just does the job right, you will drive the car better because you're not worrying about whether you've switched the wipers off and they're stuck halfway up your windscreen, or if you've pressed the indicator and it's been going for the last 20 minutes and the bulb's melted the lens, because we've had that before. So we have 3 models. Each model has varying expansions in their range. We have a Logic 1, we have a Logic 10, and we have a Logic 24. And what we'll show you in a minute is our Logic 10 on a display board, and we can illustrate quite how you can reduce the wiring and how not having relays and fuses, which are hard connected with wires, you can change functionality at will. So at the moment, if you've got a heated windscreen that's connected up and you don't want it to work when you're accelerating hard down a straight I'm using this as an out there suggestion, but you don't want your heated screen on while you're accelerating down the straight, you can program the BCU to turn the heating screen off when you've got full throttle. That's at the advanced end of operations, but it helps to explain the difference between fixed relays and fuses and a body module or a PDM where you can program the functionality. We've moved over to another display stand to show you the BCU Logic 1, which is our key product in the BCU range. It's ideal for your smaller 7-type vehicles. And this is what you can reduce the wiring down to. And this wiring is all the power outputs for all the consumers that we've discussed in previous videos. And it's also all the switching coming in from your column stalks, your dash switches, your ignition key. The advantage of using a body module is that you're not fixed in how you control the outputs. So you can have a wired switch to trigger your side lights and your headlights, but you might want a flash button on your steering wheel. And that brings us back to your wireless steering wheel. And the whole point of the body module system and the electronics and the advantages that it gives you is that you can have and or operation, you can have a switch on your dashboard and you can have a duplicate switch on your steering wheel. Or you can have a switch on your dashboard and you can have the trigger circuit for your flash or your horn on the steering wheel. And if you decide to do that, you can actually reduce the wiring even more. And you can slim the wiring down from this particular setup, where we have 68 wires. You can slim that right down to only the wires you need for the power outputs to the various consumers. We're calling them consumers again, your lights, your wipers. We can offer various functions with electronics which you can't do with a hardwired system. Once you've wired your hardwired relays and fuses, you are fixed to that function. Whereas the electronics allow you to blend systems together and have things happen which you didn't have before. It also allows you to have one or more switches do multiple jobs. A good example here is the wipers. We don't want to fill the steering wheel with an intermittent position button, a speed 1, a speed 2 button. If you have one button, you press the button and we're now in intermittent mode. You press the button again and we'll now have speed 1. We can press the button again, that's speed 2, and then you press it again and it stops. We also have a function that I can't demonstrate on this because it's not switched on, but you can hold the button and it will remember the time you held it and it will give you a variable intermittent. So you can adjust the time of your intermittent. Not that it applies to most Caterham owners or Westfield or kit car owners, but if you're in a vehicle, if you're building a vehicle slightly more, a roofed vehicle, then that sort of thing can be really easy to do with electronics and really difficult to do with hard wiring. It simplifies things as well because we go a lot for safety and simplicity. So we've got switches up here and each of the switches is earthed. So in the older type of fuse and relay system, you would probably go battery to a fuse, the fuse to a relay, or a fuse to a switch and then to a relay, or some combination of that. Because we bring power into the BCU, the fuses are all internal, the switches are just signals. There's no current there, and we switch them earth because in the older systems you'd feed power to a switch. If that wire got damaged, that would blow that fuse and you might lose multiple circuits. Whereas here, the worst that can happen is it puts that function on. So it simplifies the wiring, makes it safer, and it makes it much easier to wire. And it means also you can run smaller wiring because all we're doing is sending a message to the body module and requesting you put that function on. So requesting the brake lights here. It's just a little earth. It also allows us to add my pet thing, safety interlocks. So a crash switch, which you can still put on your race car or your track day car, and if you mount the switch correctly, you won't have any issues. And that device means that if you go off the track or you happen to drive into the back of the bus because you were admiring yourself in the rear view mirror, the engine will shut off, the electronics will shut down, it will turn the fuel pump off, and it will stop the vehicle catching fire. Whereas the older relay systems, to achieve that sort of interlock is much, much more difficult, and you have to have many more wires and you have to have latching relays that start to get complicated to use. Now, I've been discussing fuses and electronics in great depth, but it doesn't necessarily make the great sense, so I'll just grab something and show you. This is the internals of one of our body modules. This is the Logic 1, and it does have fuses in it, but they're not as you see a fuse, a little blade with a little wire that when too much current is drawn, it pops and that's the circuit blown. This has electronic fuses which monitor a current, and when it reaches a certain level, it switches off automatically. When you've repaired the damage, it'll just switch back on. And this gives us an advantage that if you happen to have a smart dashboard, we can send messages from here to tell you that the fuse has blown. But it hasn't blown, has it? It's just stopped working while the fault is corrected. Whereas with your fuses, if a fuse blows, you've got to put a new one in. And if you haven't corrected the fault, that fuse will blow again until you correct the fault. And if you keep putting fuses in, all you'll do is keep blowing fuses. This type of system means that the power is switched off to that circuit until you repair the fault. And as soon as the fault's repaired, the electronic switches them back on because it detects that the fault has now been fixed without going into too much detail. We also use this particular type of component here, which is called a polyfuse. And that again is an electronic device that's very accurate. It's more accurate than a normal fuse and means that if that circuit is short-circuited, it will turn off until you repair the fault. And combining that, so that replaces all those relays I showed you earlier. Here we have some relays in this board and our electronic components on the rear here, and they give you a much more advanced functionality. They replace the relay, but allowing us to control it with the software in there, which means that if you want to change its function or its operation, we can just change the software, adjust the settings, and you have access to this. So we pride ourselves on putting into the electronics a lot of pre-configured settings. So functions for IVA, control functions for fuel pumps and cooling fans, heated screens. But what we do give you is a drop-down list. You can plug the laptop into this, you can find the drop-down lists, and you can select if you have, I'll give an example, fog light is just a fog light, but if you're going on a track day or you're racing, you might want to use that as a rain light, and that works completely differently. So you can go in and you can select it as a rain light or a fog light. And that's just one example of a number of things we can change on that. So in summary, really, the BCU was designed by us to help you improve the system functionality and reduce the system complication and make it easier, if you want to do these things at home, to build your own wiring systems. Now, having discussed all this technology, one of your first questions might be, what if it goes wrong? Well, we're very lucky in the fact that modern technology rarely goes wrong. And we have been producing these for a number of years, and unless it's been physically damaged, we've never had an issue. However, we do support our products, whether it be body modules, wiring systems, or design support. We will support it forever. We don't warranty it forever. It has a 2-year warranty on it. But if you have a problem with one of these in 5 or 6 years' time, you can return it to us and we will test it and we will work out whether we can repair it or not. And we design the system in-house. We do our own software, so we are completely on top of it, and we build these in-house. So it's wholly British designed, wholly British manufactured, and wholly British supported. And when you're thinking about system design, if you think about your system design and you choose one unit, but later in the car's life, these units can be returned to us for upgrade because they are designed to have a number of upgradable options. So you have absolutely no worries that if you buy one of these units, we can support it for as long as you will have the vehicle. I hope you found this video helpful. If you need any more information, be free to contact us by any means. Check out our other videos. We've done more videos on how to design the harness, how to mount equipment, and other considerations when you're designing, building, or requesting the purchase of a wiring loom. Thank you very much.